Hello, Austin. It's great to be here. I know we all had some delicious tacos for lunch. Hopefully it doesn't put us all to sleep, but we're going to have some fun here regardless if you fall asleep or not. So, as I said, I'm Jared Short. I'm the Director of Innovation and Awesomeness at Trek 10. Now, what does that really mean? It means that basically I get to go play with all the fun tools and experiment, and once we've figured out the things that we think work well, we can take them back to our clients and try to operationalize them and things like that. So, one of the things that you hear about serverless, one of the complaints is, but it still uses servers, right? I think we're kind of past that phase here at this point. But more importantly, to me, serverless is kind of this thought process and this approach that your architecture, and for any given segment of it, there's really no need to over-provision or pay for things that you don't need. But more importantly, there's a clear path for painlessly scaling. One of my favorite ways to illustrate this, early at Trek 10, we're an Amazon consulting partner, and there was some features in Amazon that we might want to leverage down the road, but they actually cost a fair amount of money. And our client said to us, well, if it's just a checkbox and money, who cares? Like, right? It's the easiest thing in the world. Checkbox, money, we're done. So taking that approach and looking at it in a serverless fashion, right? If it's just a checkbox and money, like, I'm happy with it. When it comes to scaling. Another important thing to realize about serverless, and I think we've kind of got some talks about this, and we're pretty comfortable with this now, is that APIs are really just the tip of the iceberg, right? Serverless isn't just functions as a service, it's not just APIs, it's really just rethinking architecture. So some of the use cases that we've seen, some fairly typical usage around, I guess, is analytical processing and ETL, right? Using Lambda fan-outs, where one Lambda function can fan out to multiple Lambda functions, do massive data processing. Ad hoc queries, Athena obviously came out, Redshift, Spectrum, all of these services can really do these ad hoc queries and analysis without clusters, without thinking about it ahead of time. More recently, people have started thinking about things like event streams, really. Your system is telling you when things happen, you don't have to ask, there's no more polling. Things like media management and manipulation. You have these events, something goes into S3, and you can do management around that and change it or mutate it, put a watermark on it, change the sizes. Content indexing is another interesting use case for this, right? There's some events, some new content, and you use those streams off of a Dynamo table or things like that to actually go and index it into Algolia or other search services, Elasticsearch, things like that. Some really important ones that I really enjoy is the security monitoring and remediation in almost real time, this business real time, where a security group in AWS has changed, or you're getting many more events coming into your system from a particular IP address than you expect. And you can respond to those events and immediately start a remediation process and roll back that security group change, right? 22 was open to the world, let's roll that back. Lambda step functions or state machines and workflows is a great example. And then a really interesting space for us that we've seen a lot of interest in from clients is IoT, rules and triggers from device state and things like that. Now, I'm sure you're saying, Jared, you said this is about single-page apps. What are you talking about, right? So it turns out, even when we went to go build single-page applications, basically behind every one of those, it turns out that there's like databases and APIs and background jobs and static file serving, logging, search indexing, you get the idea. There's a whole bunch of stuff that's behind that single-page app. So it's really important to us that we kind of take this holistic approach to serverless. Yeah, sure, single-page apps are awesome, and we're going to talk about those. But it's very important to realize that it's the ecosystem behind that that's also important when it comes to serverless. So if we step back and take a look really at the basics behind single-page applications as they existed before and as they exist now, right? There's these approaches where you have a CDN and an object store or a file store like CloudFront and S3. Tried and true, works great, right? Your static assets, your CSS, your JavaScript, your images, they go live in S3. Your index HTML is what you serve back out of S3. It works great. You can even do some hacks and get some weird path stuff where you have like a hash path that converts to a normal URL or vice versa, and so you can have nice, pretty clean, shareable URLs. Works great. And then you have API gateway, and you set up this API gateway with lambdas behind it, and you have a serverless API, right? REST, GraphQL, JSON, API, who cares, whatever. I don't care. Now, you can also use API gateway to do things like proxy to AWS services, map to your legacy services through that same API. It works great. Now, something I want to talk about on API gateway that I discovered through some experimentation and tinkering and just trying to really push it to its limits, it's not just JSON, it's not just XML. You can proxy, and importantly, you can proxy almost directly to and from API gateway through lambdas. This means you can do things like set cookies and content types, things like that, which actually means, and this was the most exciting day of my life, kind of, that you can do HTML, right? It's just bits and bytes over the wire. API gateway can serve HTML, which means, this is super exciting to me, you can run practically unlimited, really, really small little servers to dynamically render HTML and serve it back to browsers. You can facilitate all of your dynamic HTML needs through API gateway, through lambdas, in a completely serverless fashion, right? So what does this mean? You can do some really awesome stuff. If you have an Express.js application, you can go ahead and just stick that in a Lambda function. Actually, AWS even provides a really easy way to do this. They have a library. Go look up AWS Labs, Express Lambda, I think it's called. You can just shove an Express application, Express.js application, into a Lambda, and you now have like an infinitely scalable Express.js application. You can do the same thing with Django if you go look at the Zappa framework. So anything that can serve HTML, take in requests, serve back HTML, you can do it completely serverlessly. More excitingly, if you're part of the cool kids group or really innovative people, you can leverage server-side rendering. So if you have React application or Ember or Vue or anything like that, you can leverage these server-side rendering capabilities. And so on the front end, you still get to leverage all of the API and normal reactivity that you would get from JavaScript, that performance enhancement perhaps. But when people go to specific paths, you can still render all of that HTML and serve it back without having just to serve back a blank index page or a simple index page and then have to pull in from that API request afterwards, right? So you don't have that initial load hit. This is great for SEO, first page load performance, and you can appease the no-script crowd. So Google can scan your sites better because they can just get the HTML back. It doesn't need to worry about can it render all of the JavaScript in this single page application and walk your directory trees. And then insanely scalable, just like you would expect from serverless. So I actually have a video of a demo here, but we're going to try the live demo. If that doesn't work, we're going to do the video. But you'll see right here, this is a client of ours. They built this really clever game wiki API service. But essentially, if you look right here, all of this is actually just rendering with, it's a React-driven site, and then we're rendering in the lambdas of the HTML on the page loads, but then you can traverse it just like you would a normal JavaScript application. It's going a little bit slow here, but we'll see if we can get in here. So you can see I can navigate around the website. I can jump into a post, and you'll see I have things like this JavaScript capabilities. It's trying to load a Twitch video. So JavaScript is certainly enabled right now, but if I turn JavaScript off, it will refresh the page here and see what happens. It still works, right? My JavaScript is off, and it still works. Interestingly enough, one thing I'd like to point out, this is really, really hard to do, and I know that if you go to a small little startup called Facebook, they pretty much just tell you, too bad. Like, turn on JavaScript, right? So we're outperforming Facebook when it comes to this. So simple reference architecture. Basically, it's everything I said, right? Somebody requests the website, the HTML, whatever you want, even going to the API. And we funnel it through WAF, so we can try to filter out bad actors and bad requests. We hit CloudFront. CloudFront, actually, we put that in front of two different API gateways. One is rendering the content. So we have API gateway to a Lambda that is just rendering stuff off of our data store. You can actually do things like your rendering Lambda pulls off of another Lambda as well that is running your API, and you can skip additional API hits. We actually essentially just render off of our data store in this particular case. And then CloudFront goes to another API gateway for a GraphQL endpoint. And that goes through another Lambda that's running our GraphQL resolvers, which then hits the data store. So that's one approach to it, one exciting thing. If you look at the data, it's actually really, really darn fast. So this is this particular site is actually all hosted in Tokyo, the Tokyo AWS region. And I just ran a really, really quick speed test like the day we released it. And with zero thinking about performance at all, easily 100 plus requests per second, with zero time thinking about it, 100 to 200 millisecond response time or faster. And that's going through WAF, going through CloudFront, going through API Gateway, doing our rendering. And you'll see the actual fastest time for Tokyo is 30 milliseconds, and then the average time if you're requesting from Tokyo to Tokyo is 53 milliseconds. So this thing is blazing fast. And then also really interesting, for this particular site, the cost in terms of compute was an order of magnitude smaller than what they were just paying for bandwidth, which is pretty crazy if you really sit down and think about it, that your compute cost, especially if you start adding in caching or things like that, it just rounds down to zero, basically. Some lessons learned, some things we like to talk about is really embrace services, not servers, right? Evaluate the time of building something in-house versus can I just fork out some money to some other folks and have them handle that for me, right? Things like auth or search, databases, media management are all examples of things that you can very easily checkbox and money, right? Checkbox and money, hand it off. Someone else can manage those hard bits for you, right? Auth0, GraphQL, Algolia, they're all fantastic examples of people that have solved very hard problems for you, and you shouldn't necessarily need or want to waste your time trying to solve them yourself. Now, that all said, I do want to be very clear here that you should not underestimate the powers of serverless and really just rethinking and taking another look at what you can do with serverless, maybe a lot easier than you think. So you can build an on-demand CDN-based image resizer in less than 50 lines of code and like literally a couple hours. I was tinkering with this and I timed it. It took me about an hour and a half from kind of initial concept from reading some stuff from AWS and then just actually building it and deploying it. So if we take a quick look at an example, we have the serverless conf, snapshot of the logo from the website, right? It's this huge screenshot. But if I jump in here and I just change this to, let's say, 400 by 700, it'll take a little bit. It's cranking through, it's thinking. But what will happen is, assuming the Wi-Fi holds out, it will come back with a completely resized image, just like that. I had no pre-rendering or anything like that. I hadn't decided ahead of time that I wanted 700 by 400. It just came back with exactly what I expected. Now, what's really clever about this is, so the first time I do it, it's really darn slow, because it's trying to do all of this. It's essentially kicking off a Lambda function and doing some resizing on the back end. But the second time I hit it, it's instantaneous, because I've now cached inside of S3 that resized image. So from now on, anytime anybody asks for that size of image again, it's going to be instantaneous, and it's never going to run another Lambda. So we went through the demo there. I'm not going to talk through this code, but I wanted to prove it. Like, this is literally the only code that is running in that Lambda function. It fits on a slide, which is, it's insanity that you're able to do essentially something like Cloudinary or something that you would pay a lot of money for. I got all the function I needed out of Cloudinary for a slide worth of code in like an hour and a half. So don't underestimate rethinking. This is the architecture for that. Fairly simple. We go to CloudFront. We check in S3. Do I already have that file? If I do, I'm done. I return it straight back. If I don't, you can use some tricks and say on a 404, on a not found, redirect to API gateway, And then from there, talk to the Lambda and resize the image that we know about from the URL, put it back in S3, and then we actually return another redirect back to CloudFront to the user. So we send them kind of in a small little loop, and then they go and pull it out at S3 for that final round trip. So that's just one of those powerful use cases that you just don't necessarily consider unless you really sit there and think, how can I take the serverless paradigm and really apply it to this domain? What worked really, really well for us? GraphQL, which we've heard a little bit about today at this conference, plus serverless, plus single applications means like I get to sleep. Part of our business at Trek 10 is this 24/7 managed offering where we get all of the alerts, come to us first. And that can be painful, especially if you don't have these super scalable systems in place. Maybe someone screwed up configuring an auto-scaling group. I get to wake up, right? I have never had to wake up for a GraphQL serverless single-page application setup. In addition, like we went through, image resizing works fantastic. We've worked on systems that do millions of image resizing activities per hour, and they just work flawlessly. It's fantastic. Event streams for throttling. Excuse me. So you can feed off of DynamoDB or things like that, and actually, when you're trying to talk to those legacy systems, you need some kind of queue in place. Especially if you're trying to go to an RDS system or an older legacy API or things like that, you probably need something in place to protect those legacy systems. Otherwise, you can very easily, with a serverless system, scale almost instantaneously and very rapidly, just completely trash your older systems because they can't take that scale. So using things like DynamoDB streams for throttling or synchronizing to those legacy systems is a great practice. And then something else that is really exciting to us that's been fun is a total abuse of the AWS IoT service and ecosystem. But we essentially create WebSockets and create the browser as a device in IoT and send back essentially real-time notifications from event streams or things happening in Lambdas. So you could even do an IoT chat platform where you just have two browsers and two folks are just talking to each other through these WebSockets. And also just typical browser-type notifications back through IoT. So that stuff actually worked really pretty well for us. So one thing that I think is important to talk about, there's been a lot of talk here at the conference about it, is GraphQL. And we've actually done a lot of GraphQL work, and more importantly, serverless GraphQL work. So I want to go through a few of the things that worked fantastically well for us and really get that knowledge out there. So just a brief overview, if you're not completely aware of what GraphQL is, it's this idea of just one endpoint is representative of your API. All of your data access can be represented through essentially a graph, right? So graph query language is what it is. It provides an easy-to-understand API layer for all of those many resources behind that single endpoint. You can actually map, for instance, to a REST API and an RDS instance, a DynamoDB table, and then not have to expose all of that complexity to the end developer that's making those requests. More importantly, you only get exactly the data that you asked for in the same shape. And we're going to go through a quick little example of that. But it's really powerful in that you get essentially this optimized data request model out of the box as a result of some of this other fantastic technology. So if your desktop application needs to display more data than your mobile application, you just swap out a few nodes in your request, and you now get exactly the data that you need for either one of those platforms. It has some other side effects. Streamlined API iteration. If you need to add new nodes or you need to add new requests, it's very easy to do so. New endpoints, fairly easy to do so. Extensibility is fantastic on it. And then the GraphQL community is almost second to none when it comes to actual support. The creators of GraphQL themselves are super active when it comes to responding to GitHub issues and actually iterating on the projects themselves. And then the tooling around it and just the community is fantastic. The only parallel I've seen really is actually the serverless community itself is also quite up there. So if we take a quick look at an example, there's the Star Wars API, which is actually a REST API. It's kind of an example of how to build a REST API. The Facebook guys, GraphQL is a Facebook technology, in case you didn't know. The Facebook and GraphQL guys went ahead and actually wrapped that REST API with GraphQL, so you can see it. And this is one of the tools. It's called Graphical. One of the powerful parts of GraphQL is because it's this typed schema definition, you can get and find out and explore very easily, even as someone that's completely inexperienced in GraphQL itself, or you know nothing about the API you're about to work with, you can very easily just explore the data model and start tinkering around with all of that data, right? So it actually has this concept of autocomplete is built right in. So if we're talking about Star Wars, I can ask for all of the film titles, right? So there we go. I've just asked for all of the film titles with that little bit of request. Now, say I'm building a slightly more advanced view. Let's say I want to know all of the characters in each of those films. And let's say I want to know their name and let's say how much they weigh. There we go. I get it back. So Luke Skywalker in A New Hope weighed 77 something. I have no idea what. So yeah, that's really the power of GraphQL, is that I can just ask for whatever I want to know, in this case about Star Wars, and learn from the API. And very quickly, anyone can just start drilling through and auto-completing and finding out what they want to know. And this tool, you can point it towards even your own built GraphQL systems and start exploring it just like this. So why serverless GraphQL? Why is that such a good pairing? So it turns out you get all of the normal serverless wins, which is scalability, availability, all of that great stuff, and you get all of the power of GraphQL. In addition, you actually get some cool benefits, which is smoothing out some of those rough edges on GraphQL that they don't really tell you about when you're reading the manual. Things like resource exhaustion attacks can be pretty easily mitigated. You can build some fairly complex resolvers and leverage some of the fun parts of Lambda and some fan-out stuff. And we're going to talk about these two things in a little bit. But taking these two approaches and putting that serverless and GraphQL together has been some pretty tremendous wins for a couple of our clients. So I did mention resource exhaustion attacks, and I like to show people this to give you a really good example of what a resource exhaustion attack could even look like. So right now I'm asking for all of the films and then each of the characters in all of those films. So it turns out I can actually ask GraphQL for the films for each of the characters, right? So now I have the title of each of the films for each of the characters, but I can actually ask even farther and say, I want to know all of the characters in each of the films for each of the characters for all of the films, right? So if you do this, you'll actually see that, I'm sure Facebook loves me doing this. Do the name here. This will actually take a while because it's go really fast in this case. But usually I can just keep recursing that graph, and there's nothing that's going to stop me. So I can just say, yeah, just keep giving me more of the films for all of the characters, for all of the films for each of the characters, for all of the films. They love it, right? You can do that, and nothing's going to stop you. If you nest the graph deeply enough, your request deeply enough, you're just going to blow out all of the resources on that machine. Also, another great thing I talked about is this idea of complex resolvers. This is what I was talking about. You can actually have a single Lambda endpoint. Your request comes into that GraphQL endpoint. And from there, you can look at each of those resolvers and the data that's being asked for and actually spin them out to separate Lambda functions and say, this Lambda function is going to go get the data from DynamoDB, this Lambda function is going to go get it from RDS, something else from your REST API, some other legacy system, SOAP, XML, whatever. All of that can then come back and then aggregate through that single endpoint. All of that complexity is abstracted away from that front-end developer, the developer actually asking for that data. And more importantly, you can have separate teams maintaining those kind of different endpoints in parallel, and then your GraphQL just has to ask for the data it needs from those different endpoints. You can also just do this for really expensive queries, right? So if you have certain bits of your resolvers that you know are just doing a lot more data aggregation or things like that, you just spin that out to a separate process, essentially, and then it can handle it. Because the key part is each of these particular Lambda functions gets its own set of resources. That's one of the powerful things. If you provision a gigabyte of memory, each single Lambda function gets that to leverage that gigabyte of memory for themselves. So I talked a little bit about those resource exhaustion attacks, demoed it. You can basically just think about it as a DOS attack that's really easy to do against yourself. But the powerful part is that you can look at in the graph and say, only allow maximum depth of like 3, which would prevent bits of what I did, so I couldn't just keep asking down the graph. You can assign scores to each kind of resolver, and if an overall query exceeds a given score, we're just going to throw it out. And then there's also some big wins with like request batching or caching, where if you've asked for data for a film already once, you don't need to ask for it again if it somehow shows up somewhere else in that graph. So when it comes to resource exhaustion attack mitigation, doing it with serverless GraphQL is actually quite a fantastic approach, because each GraphQL execution is allocated its own resources. So what you can do with Lambda, I'm sure you're aware, there's timeouts, right? They can be really annoying if you need it to actually complete. But if you presume that any valid query should pass in 10 seconds, otherwise they're doing something very bad and you wouldn't expect them to do that kind of query, you can just say, all right, we're going to set our timeout for 15 seconds, and if whatever they were doing exceeds the 15 seconds, we're just going to time out and throw out that request. And that gets you like 85% of the way to just mitigating a bunch of the mean attacks. In addition, you can also throw your web application firewall on CloudFront in front of that endpoint and just mitigate people that are trying to hammer away at your service. Now, I talked about GraphQL and kind of building your own stuff and the mitigation of resource exhaustion attacks and all of that good stuff. There's actually an easier way to do GraphQL that's become, it's a company called GraphQL. They released actually a few months ago. And it's really exciting to me because I think they're the first service that I've seen that is really leveraging this idea of serverless and building it into their core, right? So they make it really easy to work with GraphQL, set up your schemas, they'll manage your data stores for you, provide the API layer. But more importantly, it's something that I think we're going to start seeing more of, is that serverless and event-driven architecture is really built into their core. What I mean by that is that when you have data mutations, or when you have certain kinds of queries or permissions, they can hook out natively to like your Lambda functions, or they're building for other providers, I believe. And they will actually execute in an event style those external resources, kind of passing along that data, and make it really easy to just extend and build on top of their platform. And I think we're going to start seeing more and more of that. So my final thought is, if you actually are one of those people out there that's building a product or a platform, whether it's actually internal or external, think of providing events for all of those relevant operations. We've heard a lot from other folks about this, but those event streams, I think, are going to become very critical. One thing that I've said before is events are the new webhooks, right? So they're actually a vast improvement on webhooks, but you can kind of think about them as being notified when that thing is happening that you need to take action on. I think providers throwing out easy execution of your code in sandboxed environments or those self-hosted functions is going to become very popular in the future here. Auth0, GraphQL, they provide these essentially API-driven or point-and-click interfaces to just stick in your own code to run in response to or as middleware as part of the request in their system. And then more importantly, just integrate with those existing event platforms or just platforms in general as much as you can. The serverless framework, the just direct function as a service execution in Google or Amazon or Azure or anything like that. Use, if you can, the native auth systems that are built into those providers as well. So IAM roles, right? I shouldn't have to give you AWS keys for you just to execute my functions. I should just be able to use like cross-account IAM roles or things like that. And then just offer those pre-built and modular, like reusable extensions, give people great examples. All right, so that's my talk. Thanks for listening. And I actually think I have a few minutes for questions if anyone has any. And I cannot see. Red shirt.
Yeah, how are you integrating Webpack?
Webpack.
Oh, Webpack. So into the builds?
Yeah. So I would consider that more of a front-end kind of tooling and integration than anything. So a lot of what we do is once you've done that build, so there is some tooling. Are you talking about specifically like the server-side rendering stuff, or? Yeah, so that does get a bit tricky. Certainly you have to take care to basically, as part of your build process, you have to distinguish whether it's going to be the server build or the front-end build. So one thing we do is essentially just have that split in Webpack. There's some configs in Webpack you can do, and then you just, we do actually 2 separate deploys. So you have your assets go off to S3, and then your server build goes off into the Lambda function. We have like 2 different processes to build those out. Does that answer the question? All right, right behind you, yeah.
Now, when you're storing data in S3, what type of performance are you seeing with your Lambda requesting data from S3?
Lambda requesting data from S3? Anywhere from probably the double-digit milliseconds. Anywhere from, you can get it pretty fast, like 10 to 15 maybe, up to, it can take a while.
Depends on the size of the file.
Yeah, it certainly depends on the size of the file, but it can take a while. For a normal image, it's probably, and other people might have a better idea. For like a normal, like 100 kilobyte image, it's probably less than 100 milliseconds, maybe a little bit more. Any other questions? Awesome. All right. Well, thanks, guys.